So previously we discussed about sequence, sequence item, and then sequencer, okay, driver. Okay, same way we need to execute. We need to explain what are the components are there, what are the things we need to represent in monitor. See, monitor samples the DUT signals. Okay, simply monitor is so observe the signals from the DUT. Okay, whatever the signals are getting from the DUT, so it will observe that through virtual interface. Okay, so through virtual interface, it will observe the signals. Similarly, here what are the components we need to write means so the class representation. So the monitor is written by extending the UVM monitor. UVM monitor is my parent class. Okay. So memory monitor is my child class. Okay. So I am creating the child class from the parent class by using extend keyword. After that, class registration. Tick UVM component details. What is that? Tick UVM component details. Memory sequence item. Sorry. What is the thing here represented? Memory monitor, right? So that is my class representing using component details memory monitor. After that, constructor, custom constructor. By using custom constructor, we can call the parent class. That means super.new name comma parent. That is calling the parent class here, and then virtual interface. So through virtual interface only, we are collecting the signals from DUT to monitor. Okay, so monitor it will, what it will doing means whatever the signals, that means transactions is receiving from the DUT, so that are pin level, then it will convert into packet level through virtual interface. Okay, so connect interface to virtual interface by using get method. So how we are connecting the interface means, see, this is the virtual interface, right? So we are creating the config DB, we are getting the config DB for this virtual interface. See, function void will face UM face super dot will face. Then if not using config DB, virtual memory interface, this is my interface representation. Scope resolution get this for this component empty space for global, and then your string name is VAF. Okay, so then it is stored into VAF also. Okay, we are getting the data from string name is VAF and then stored into VAF. If we are not getting the config DB, then I am getting the no virtual interface. Okay, so then after that, we need to declare the ports. Okay, declare the sequence item handles, and then there is a sequence item collected port is there because we are implementing the ports by using implementation ports. See, I think here there is no implementation port represented here. So this is the implementation ports. Okay, so in the implementation ports, we are representing memory sequence item transaction collected. Okay, so transaction collected is my handle. Then here sampling. How we are sampling that? Sampling the interface signals and assign to transaction collected ports. So what is the sampling logic? Here we are placing means for our loop we are using. See, virtual interface. Okay, so virtual interface I am using virtual task run phase phase forever begin sampling the logic. See, at the rate passage clock monitor dot clock. Okay, I am using monitor dot clock. Similarly, wait if monitor dot vf dot monitor clocking block write enable or read enable. So if you are doing write enable or read enable, okay, so anything. If it is anything one means it is doing write or read operation. Okay, so transaction collected dot address equal to vf dot monitor clocking block dot address. Same way, we are giving the address to, we are collecting the address from the DUT and assign to transaction collected port. Okay, handle. Similarly, write enable. So write enable and write data. So waiting for the write enable begin and then write enable. After that write data we are giving. Then transaction collected read enable equal to 0. So while doing the write, read enable should be 0. Okay, and then end task. So here forever begin we are ending this begin. Similarly, if vf.monitor.clocking block dot read enable, that means we are doing some read operation. So while doing the read enable, we are doing the read operation. Then I am using that clocking block read enable to vf.read enable to transaction collected dot read enable. We are assigning that. Then write enable should be equal to 0. After that, I am waiting for clock. Then transaction collected should be read data. Okay, whatever the read data we are receiving, that should be assigned to transaction collected data. So how we are connecting monitor to scoreboard means the transaction collected port dot write method we are using. This write function we are calling on scoreboard. Okay, so then the handle is transaction collected. That's it. Okay, so this is complete code. How we are representing class memory monitor extends from UVM monitor, and then virtual memory interface, and then UVM analysis ports we are implementing. UVM analysis ports your transactions, that is memory sequence item, and then my handle is transaction collected port. Okay, so then I'm taking that memory transaction memory sequence item. So then the handle is transaction collected. For these two, I need to create the memory in custom constructor. So this is my class registration. This is the registration of class to what factory, by using factory registration I'm registering my class. Okay, after that custom constructor, in that custom constructor what we are using function new string name comma UVM component parent, and so for of new name comma parent we are getting the parent components here. After that transaction collected equal to new. Okay, so then I have created the memory to transaction collected. Similarly, item collected equal to new of item collected port comma this. So whatever the item collected port we are creating the handle, for that we are creating the object here. In function build phase we are representing, we are getting the config db. Okay, how we are getting the config db? Function void UVM phase, function void build phase UVM phase. Okay, after that super dot build phase UVM phase. Okay, super dot build phase. So phase component we are getting that from the parent, and then UVM config db, not UVM config db virtual memory interface scope resolution this comma vf, same thing. Okay, then we are getting the virtual interface. Then task run phase. In run phase, virtual task run phase, UVM phase forever begin. We are doing write operation and read operation here. Okay, so this is complete code of monitor. Clear? Similarly, same thing here also there. Okay, monitor, I told you that monitor observes that DUT interface and create the transactions form. So creates the transaction form. That means pin level data to transaction form means packet level data. So pre-level activity it sends these analysis ports and ports for checking. Okay, so it is sending that your analysis ports are working or not. Okay, same thing. Class registration. Class example monitor extends from UVM monitor. Here also I am using that UVM factory registers with UVM factory. That means take UVM component details example monitor we are using. Okay, and then I am using the interface. Whatever the physical interface is there, for that I am creating the virtual interface. Virtual example interface is the VAF. Okay, so VAF I am taking here. Okay, after that, analysis ports. UVM analysis ports. What is the analysis ports we are representing here? UVM analysis ports, example transaction, item collected port. Okay, so this is the transaction. Again, example transaction is my class for related to example transaction is related to sequence item. For that, I am creating the handle that is transaction collected. Okay, so then custom constructor, by using new method we are creating the memory for that. Okay, we are creating the super token name comma parent, and then item collected port equal to what is that new of item collected port comma this. Okay, again transaction collected port equal to new. So that way we are creating the object here. After that build phase, function void build phase, UVM phase, super dot build phase. So we are creating the build phase. In that I am getting the type name. Okay. So what is the type name I am getting here? Okay. So get type name and then building monitor UVM height. So this is the verbosity level and description I am mentioning. Okay. And then config DB we are getting. So config DB. So what we are getting the config DB virtual interface get this comma and this space VF comma VF. If you are not getting, I am getting the error. UVM pattern get type names failed to get the virtual interface from the config. Okay. Again, run phase. So how we are declaring the run phase here? So virtual task run phase, event phase. Okay, so this is the virtual task run phase, event phase, and then wait for reset. That means wait if reset VF dot reset equal to 0. Then it is waiting for up to 0. After that, I'm taking that for our begin. Then transaction collected from DUT interface. See, collected transaction I am writing here. Okay, so this is the collected transaction any task. So in that virtual task collected transaction I am writing here. So collected transaction means whatever the signals we are getting from DUT, it will convert it into transaction levels. For that I am creating the memory transaction collected equal to example transaction type ID create transaction collected. Okay, and then see we are doing some write operation and read operation. Write enable equal to 1 or read enable equal to 1. Any one should be 1. So based on that it is doing the write operation and read operation. Therefore transaction collected address equal to VF dot address and then byte enable we are taking the signals in our sequence item, right? So same signals we here also we have written. Same. If VF dot write enable begin transaction collected dot type data equal to write operation we are doing. For write operation I am getting the data and then read operation also I am doing that. So for read operation just ready should be 1. Okay, if it is ready should be 1, it is collecting the data. So then I am receiving the data VF dot data. Then collected dot timestamp equal to dollar time. For that, why we are using that? So placeholder wait for transactions. That means timestamp should be printed. If you are not getting that, then you will get the error like get type name you will dollar $s format transaction collected dot convert to string. Okay, so whatever the data we are having that should be converted into string format. This is the monitor connection. So we need to connect the ports, right? Item collected port dot write method and then transaction collected. So transaction collected is that sequence item handle and then item collected port dot write method we are implementing. This write method we are calling in scoreboard. Okay. So next UVM agent. What is having UVM agent? The UVM agent encapsulates that sequencer driver monitor for single interface. Okay, so for a single, and then interface it can be active with driver or passive monitor only. Okay, so agent it can be operated in two types: active agent and passive agent. If you are having active agent, then your interface should be passive. Sorry, active means driver is there, and your interface should be positive. Passive means so only monitor only there. There is no driver and sequencer. Okay. See class. I'm creating the class here. So class example agent extends from UVM agent. So UVM agent is my parent class, and then example agent is my child class. I'm creating the class by using this class only. I want to write all the things. Okay. So then registration, factory registration. So by using the factory registration, I'm calling the class from the anywhere. So just factory registration, I'm registering my class with UVM factory. Okay. After that, agent components like example sequencer, driver for driver, and monitor. So these are the handles we are using. See, analysis ports forwarded from monitor. See, how we are implementing UVM analysis ports. So example transactions item collected port. Okay, so same thing we are implemented in monitor side. Same here also is implementing, and then custom constructor, we are creating the memory, and then function void build phase, we are getting the monitor handles, right? So we are creating the memory. So just always create a monitor equal to example monitor type id create monitor comma this. Similarly, this is passive. Okay, if it is passive, then monitor only there. If it is active means, so create for active means sequencer and driver also there. Okay, so then I'm getting the config db if get is active equal to um active begin. Okay, if it is active, then sequencer equal to example sequencer type id create sequencer comma this. Okay, so in this way I'm creating the object here by using create method, type id and create method. Driver equal to example driver type id create driver comma this. Okay, in this way we are what you call it? We are creating the components. Okay, so by using type ID and create method, we are creating the object during runtime. Okay. After that, connect phase. You virtual function void connect phase, phase. Okay. Super dot connect phase. Same way, if get is active equal to active, I am connecting that driver dot sequence item code dot connect sequence item code dot export. Okay. In the connect phase, I am assigning that item collected port equal to monitor dot item collected port. Okay, so item collected port equal to I am connecting the monitor. Okay, so based on that item collected port, I want to connect the scoreboard. This is my agent port. Similarly, scoreboard. Scoreboard is comparing the actual values and expected values. Okay, actual values are getting from the monitor that is receiving from the DUT, as well as expected values are getting from the reference model. Okay, so reference model we are using. See, class example scoreboard extends scoreboard. Scoreboard is my parent class. From that, I am creating the example class child class. Okay, so example scoreboard, that is my child class. Tick component details example scoreboard. So this is the class registration by using factory. So we are creating the memory during runtime. Okay, we are registering during runtime here. Okay, again, analysis ports to receive transaction from the monitor. See, analysis ports in these two components are there. One is my sequence item and other one is scoreboard class name. Okay, example transaction gamma and then example scoreboard. Then item collected port. Okay, item collected port is there in monitor. Here item collected export is there. Okay, so export is used to connect the monitor to scoreboard. Okay, so then I'm using the reference model like why we need to use the reference model means I want to compare that. Okay, compare my actual values with the expected values. So then I'm using the reference model here. After the statistics, how many checked and passed and failed we are representing here. This is the custom constructor. And then super dot string name example scoreboard using component parent equal to none. Super dot new name comma parent. Then item collected export equal to. So statistics means how many transactions you are giving, how many checked. Suppose 10 transactions I am doing that. Then transaction checked also 10 we need to get. Based on based on that, see, we are checking that. So in the sequence item, I am giving my number of transactions in between 4 to 16. Okay, so that means 4 to 16 values we are checking. Okay, randomly it is taking. Then how many transactions it is taking, we need to check that. Okay, so how many transactions are executing in that, how many are passed, how many are failed. So we need to check the fail count also to get past the that test case also. For that we have some statistics. Okay, so same way I'm using that function void write method. Okay, so I'm getting the transaction from the monitor and then see transaction checked is incrementing. So tick info get type name comma $s format checking transaction percentage 0d and then transaction check, and then transaction string. Okay, so we are checking the transactions, how many are converted, and then how many are executing. We are checking that, and then UVM5, that is the verbosity level. See, checking the transaction. Transaction is right, it is doing right operation, then check right. Similarly, is read, it check the read operation. If it is write is failing, doing the read operation. If read is failing, doing the write operation. Okay, so that is the if condition we are writing here. After that, function void write method. See, check write method we are writing. Okay, so I'm checking that function check write transaction. How many are doing some write transactions? Okay, so in the write transaction, store the data in the reference model. Okay, that's why we are taking the reference model. See, whatever the data I'm having, it will be stored on reference model based on the address, transaction.address. After that, I'm printing that. How many transaction data are printing, and how what is the address, transaction.address. Address and data I'm storing there. I'm printing here. Then my write transaction is completed. Similarly, check read. Okay, so class example transaction txn. Okay, so handle is txn. Then here I am taking the expected data. So similarly, how we are taking the reference model data type for writing the data, same way I'm expected data is taking here. See, if memory model dot exist transaction dot address. So in FIFO, I think associative memory method is the particular data is exist or not. We are checking. Same way, memory dot model dot exist right transaction dot address. So whatever the transaction dot address is exist, I'm getting the expected data here. Okay, so from memory model dot memory model of transaction dot address. Okay, so in this reference model, whatever the data I'm storing, that is my actual data. That should be equal to expected data. Okay, if expected data is uninitialized, okay, so we need to initialize the expected data. Okay, after that I'm comparing this. Right, transaction.read data. Transaction.read data is my actual data. That should be equal to expected data. Okay, if both are equal, my test is passed. Okay, so if we read pass and then address expected data and actual data, we are printing that. Transaction.address expected data and then transaction.read data. All the data we are printing. See, then if you are not getting, then it is transaction pass equal to incrementing, and then we are checking that how many are failed. Okay, how many are passed. So address and then failed transaction we are checking that. Then report, how we are getting the report. So function void report phase phase read phase super dot report phase phase. Okay, super dot phase phase. Okay, so info string format we are converting total transaction, how many transactions are total, and how many are passed, how many are failed. Based on that I am checking that. So check passed and failed. Okay, so based on that I will get to know how many test cases are passing, how many test cases are failing. So then fail test case, how to debug it. Okay, so that is the scoreboard code. See, if transaction failed greater than 0 begin, so test is failed. If it is a transaction checked greater than 0, and then check all the transactions are checked. Okay, in this way I am executing the scoreboard code. Okay. Same way, coverage collector. I told you right, coverage collector, same class coverage, extensive component. After the transaction cover group, transaction cover group, and then transaction type is cover point, and then transaction collected type comma. So this is the bins representation, read and write operation it is doing. Just read and write operation only it is doing that. Okay. So for that I'm assigning the bins low, high, medium. So I'm assigning different data values. Okay. Similarly, byte enable, which byte I'm having valid data up to this byte 0, byte 1, byte 2, byte 3. So any one bit is getting high. And similarly, all bytes should be high, half byte should be high, and lower byte should be high. So these are the corner cases to execute it. Okay. So then type address coverage transaction CP, comma address CP. So based on that we have created the handles. Okay, then end group. After that, transaction collected. What is the transaction collected? Example transaction. Then transaction collected is the handle custom constructor, and then function void right method. We are collecting transaction collected equal to t. In scoreboard we have implemented, right? So that should be sample here. Okay, transaction dot cg sample, and then I'm getting the data. Similarly, report phase. So how many coverages are executing, how many are not executed, reported phase we tell that. Okay, that's what.